this video is all about section 3.4, that is real zeros of polynomials. So we have seen in section 1.6 that a polynomial can have complex zeros, and it is very important for if you are going into studying higher level of mathematics, that you know which are the whether the polynomial has a real zero or how many real zeros are there, and whether all the zeros are complex numbers, etc. So you will need that information in certain concepts, like when you study something called as Galois theory or something in algebra, and when you're studying about field extensions, those are all higher level mathematics. So when you are studying that, it is very important to know what kind of zeros does the polynomial has, and especially with the real zeros. So one kind of real number is nothing but rational number. So we shall now study about rational zeros of polynomials. So a very useful theorem in this part is rational zeros theorem. The rational zeros theorem, which states that if p of x is equal to a n x power n plus and so on plus a naught, that is the general form of the equation, has integer coefficients where a n is not equal to 0 and a naught is not equal to 0, then every rational zero of p is of the form p over q. So this p over q is nothing but the general form of a rational number where q is not equal to 0, correct? Q is not equal to 0, and p comma q are integers. So how are these? P is a factor of the constant coefficient a naught, and q is the factor of the leading coefficient a n. So this theorem is very comes handy when we are about to find out which are the rational zeros. So let us now learn how to apply this theorem onto a problem. But if you have to look into the proof, I'm not going to prove the theorem for you. You have the proof in your book. So if you have to prove this, I'll just tell you the steps. So what is a zero? So a zero is something that after you substitute the number in the polynomial, it satisfies the polynomial. That is, if you substitute and simplify the number into the polynomial, it will be, upon simplification, it would give you the value 0. So that is a root. So you have to substitute p over q in the polynomial, and you know that, and equate it to 0, and check whether you have your LHS to be equal to 0, or you can find out the value of p and q and check whether it's a rational number. So that is how you prove the theorem. You can look into the book for the proof if you are interested to know about the proof. So I will do problem number I think 6 or 16. Yeah, I'm not sure. This is an exercise problem in your book. Okay, it's problem number 16 in your book, which says that p of x is of the value x cube minus 4x square minus 19x minus 14. So here the leading coefficient is an, and the constant coefficient is a naught, which is negative 14, and leading coefficient is 1. So the denominator is 1, that is fixed. Okay, so it can be plus or minus 1. So all depends on the numerator. So if you have the divisor, the numerator p is nothing but a divisor of negative 14. So what are all the factors of negative 14? That is plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14. So you have to substitute all these values into the equation p of x and check which is that number which is satisfying the equation, or which is giving you, upon simplification, a value of 0. So if you substitute 1 into the equation, p of 1 is nothing but 1 minus 4 minus 19 minus 14. So this, you can see the negative terms has a higher value and they have the common sign, and 1, it is never equal to 1, or upon you can see that it will never lead to 0. So this is not equal to 0. Therefore 1 is not a root of the equation of the polynomial. Then checking negative 1. Negative 1 is negative 1 minus 14 plus 19 minus 14. So this definitely is giving you that is negative 14 minus 5, that is negative 19. So negative 19 plus 19 is 0. So this is satisfying the equation. So negative 1 is a root of the equation. So then you have root, or you can say it is a 0. Then you have p of 2. P of 2 also doesn't satisfy. P of negative 2 also doesn't satisfy. P of 7 doesn't satisfy. P of negative 7 doesn't satisfy. Or 14 doesn't satisfy, and negative 14 doesn't satisfy. I have written down the values for you. You can check it out using a calculator, or you can try it by yourself. So all these numbers do not satisfy the equation, or upon substitution and simplification it is not giving you the value 0. So therefore the only rational root is negative 1. So the rational 0 is negative 1. So this is how you find out about the type of the 0, or what is the real 0, that is especially rational 0. So I would like to give quiz. I know that you did homework of section 3.4 in your homework 4 itself, but I would like to include the quiz part. That is, I want you to work on some even numbered problems, because that was not a part of your exam 2, and you will have questions from this section for exam 3. So therefore it is necessary for you to practice things, and it is not enough only because your homework problems contained only odd number of problems. So I want you to work on even number of problems as well. So quiz 3.4.1 would be number 20 from your book. Okay, so the next this is a the method that we learned now is like really tedious. Like, it's lengthy, and it works only if the coefficient is 1. That is the leading coefficient is 1. So what if the leading coefficient is not 1? So it is not possible every time to find out all the fractional values, and it becomes difficult once you have a fractional value and you have to substitute that back in the equation and solve it. So it's really difficult. So you have another method where you use synthetic division. Okay, synthetic division to find out the rational zeros of a polynomial. So this has steps, so I will list out the steps for you. So finding the rational zeros, finding the rational zeros of a polynomial. So step number 1 says you have to list all possible zeros. So you use the rational theorem, that is the rational zeros theorem that we learned at the beginning of the video. So use that and list all the possible rational zeros. That you can do it as we listed in the previous problem. The only difference would be you will have even the zeros in the previous problem was a fraction, but with the denominator 1, but here you will have the denominator not 1 and 0. So second is divide, that is use synthetic division. Okay, use synthetic division to evaluate the polynomial at each of the candidates for rational zeros that you found in step 1. So when the remainder is 0, you know that the quotient is obtained. So you use suppose you have something like plus or minus 1 as your rational zero, a possible option for rational 0. So you use that to divide as a C value, the C value using which you perform the synthetic division. So, and if you get the quotient in this case, so then this would be a rational 0. Okay, so you repeat. Third one is repeat. So third is repeat the process for all the possible options that you have listed out in step 1. Okay, so repeat the synthetic division process to all the possible zeros that you listed in step 1. So we will do a problem in this case. That is, if this is an example problem itself that I'm trying to do and explain. So if p of x is equal to 2x cube plus x square minus 13x plus 6. Okay, so now we have to find all its zeros. Okay, and you have to write the polynomial in factored form. So using the rational zeros theorem, you know that a rational zero will be of the form p over q, where p is the where p is a factor of the constant coefficient and q is a factor of the leading coefficient. Okay, so that means this would be a factor of 6 in this case, and this is a factor of 2 in this case, correct? So what are all the factors of 2? It is 1 and 2. So plus or minus 1 and plus or minus 2 are the possible options for the denominator, and for 6 it would be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. So options for p would be plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, correct? And options for q would be plus or minus 1 and plus or minus 2. So what are all the possible fractions or the zeros that you can have? That would be plus or minus 1, that is 1 over 1, and plus or minus 2, correct? And plus or minus 3, and plus or minus 6 over 1 or something, and plus or minus 1 over 2, and plus or minus 2 over 2, that is 1 again. So we need not consider this. And plus or minus 3 over 2, plus or minus 3 over 2, and plus or minus 6 over 2. 6 over 2 would be 3. I think we have considered 3. So again we need not consider plus or minus 6 over 2. So these are all the possible options that you have, for which you have to perform the synthetic division method. Okay, so now to check which of these possible zeros are actually zeros of the polynomial, we need to evaluate p at each of these numbers. So an efficient way to do this is synthetic division, as we mentioned in the steps that we discussed above. So to test 1 as a possible option. So what are all the coefficients of the polynomial? 2, 1, negative 13, and 6, correct? So perform the synthetic division. So 1 times 2 is 2, write it below 1, add 1 and 2, that you will get it to be 3. 1 times 3 is 3, write it below negative 13, add negative 13 and 3, you will get it to be negative 10. 1 times negative 10 is negative 10, so add 6 and negative 10, you will get it to be negative 4, correct? So this is not, this, you know, the last term is the remainder, right? The remainder is not 0 in this case, therefore 1 is not a 0. So next let us test 2. So 2 for the same coefficients. Okay, so take 2 down. So 2 times 2 is 4, 1 plus 4 is 5, 2 times 5 is 10. Write it below negative 13. Negative 13 plus 10 would be negative 3. 2 times negative 3 is negative 6. 6 plus 6 minus 6 is 0. So this is a 0, and therefore 2 is a 0 of a polynomial, of this given polynomial. So from the last synthetic division, we see that 0 is a 2 is a 0 of p. Therefore as instructed, so you are asked to write the polynomial as in the factored form. So that would be p of x is equal to x minus 2 times so you can use this to write the quotient. So that would be 2x square plus 5x minus 3. Okay, so if you continue this process, you will see that 2 is already we found out. So 1 over 2 is a 0 and negative 3 is a 0. You can check this. So your quiz 3.4.2 is 2 is check the rest of the possible values. The rest of the possible values to be zeros of 2x cube plus x square minus 13x plus 6. Okay, so you have another method that is using the rational zeros theorem as well as the quadratic formula. So that is the quadratic formula that we found out in section 1.6. So even using that we can do that. We can find out whether we have a real zero or not. So how do we do that? Suppose this is also an example problem. Suppose you have a polynomial p of x to be x to the power of 4 minus 5x cube minus 5x square plus 23x plus 10. So if this is the given polynomial, here the leading coefficient is 1 and the constant coefficient is 10. Correct? So all the possible zeros, all the possible values for zeros would be plus or minus 1, plus or minus 2, plus or minus 5 and plus or minus 10. So now using the synthetic division, I will give you as a quiz to do this. So quiz 3.4.3, use synthetic division and find the real zeros or rational zeros, to be more specific. So we are still dealing with rational zeros. So find the rational zeros from the list above. Okay, so do this. That is the same process that we did earlier. So you will have to do it for whole numbers. It's pretty easy. So if you apply that, we find out 1 and 2 are not zeros. So you have to show that that is there in the book. Whatever I am saying, it's there in the book. But use the method that I taught you and find out and show me your work in 3.4.3. So we find that negative 1 and 2 are not zeros and 5 is a 0. So once this method you learned it before, right? So now we have to use let us now learn how to use the quadratic formula. So if we I told you that 5 is a 0. So if you have to factorize this formula by one real zero that we that we found out, would be in this way. So if you do the synthetic division, you will get this quotient also, x cube minus 5x minus 2. Okay, so now try to factor this quotient. Now let us try to factor the quotient. So it's possible zeros are divisors of negative 2 because the leading coefficient of the quotient is 1. So and the constant is negative 2. So this is with respect to the quotient. So now what are all the possible zeros that we get for the quotient now? So that would be plus or minus 1 and plus or minus 2. Correct, for the quotient. So we already know that 1 and 2 are not zeros of the above equation. So this is just nothing but this is just nothing but a factored form of the above polynomial. So once we found out that some numbers are not roots of this polynomial, it will definitely be not a root of any other factor also, because if it is so, then the factor becomes 0 and the product also becomes 0, and it would contradict to the fact that the numbers are not zeros of the given polynomial. So 1 and 2 are already ruled out. They are not the zeros of the original polynomial, so we need not check that. So the remaining candidates are -1 and -2. So we have to see that -2 is a 0. Okay. That you do it again using synthetic division. So use synthetic division to find out that I write synthetic division as SD to find out that -2 is a 0. So then again, upon factorization, what do you get? X to the power of 4 minus 5x cube minus 5x square plus 23x plus 10 would give us x minus 3 times x plus 2 times x square minus 2x minus 1. Okay, so now this is a proper quadratic equation. So one such quotient is the quadratic equation. So now you can use the quadratic formula, that is nothing but x is equal to -b plus or minus square root of b square minus 4ac divided by 2a, where b is -2 and a is 1 and c is -1. Okay, so if you use that, you will get x is equal to 2 plus or minus square root of -2 the whole square would be 4 minus 4 times 1 times -1 would be plus 4, correct, divided by 2. So this would give us 1 plus or minus square root of 2, so which is again a rational root. So combining all that we found out, so we found out that you are going to find out in the quiz that 2 is a rational root, -2 is also a rational root, and sorry, this is x, yeah, and 1 plus or minus 2 is also rational root. So the list is sorry, even 5, correct. So 5, -2, 1 plus square root of 2 and 1 minus square root of 2. These are the zeros which are rational. So this would be the end of the section 3.4, because I haven't assigned homework problems from the rest of the section. So it's enough if you know this one to learn about rational functions. That is section 3.5, rational functions. So we already have learnt about rational functions, like which is very much similar to rational expressions. So the only thing is we have to express it by a rule. Okay, so and in this in the future section, that is section 3.6, we will learn how to find out the asymptotes, how to do the transformations, etc., how to graph your rational functions, etc. So this is it. This is section 3.4. Make sure you learn every day and check your emails every day. I have decided not to send too many emails. Like, it is your responsibility to learn, and also the one possible option is subscribing to the YouTube channel and pressing the bell icon, so that you get a notification as soon as I upload a new video. As I repeated earlier, that is not a promotion of the channel. You can unsubscribe whenever you wish to, and that is just after you complete the course you can unsubscribe that channel. Okay, so that is just to make sure you do not miss the video. And I have noticed that people do not listen to the video or to the instructions, and that is why you do not know why I am skipping the order of the book. So I am skipping the order of the book because I want to introduce certain concepts prior to teaching certain other concepts. so that would make your task easier. So that is the reason why I am telling that in the video. So please listen to the video properly, and I upload the same as I do the videos. I upload in the same order in Learn. You can check that. So if you have any other problems, please reach out to me. If you are really concerned, let us solve your problem together, and you can give any feedback irrespective of however small or big the issue may be. So you have to reach out to me so that I can give a better service to you people. Okay, thank you. See you soon with the section 3.6.